Hey guys, this video we're going to be looking at the counting principle and permutations. We've already done quite a bit of this. Permutations will be new though. Kind of a shortcut for the counting principles. So, or there's a formula that's a shortcut, I should say. So, the counting principle, the first experiment can be performed in m ways, and the second thing can be performed in n. Then you find the total by multiplying m times n. We've done that before. Counting principle, you just multiply. So a license plate is made up of 6 uppercase letters, 4 digits. The first 3 positions are letters, the last 3 positions are digits. How many different license plates can be made? So there are 6 positions for the license plate. 6, or the first 3 are letters, the last 3 are digits, numbers. So if there's letters, that means A through Z, that's 26, and that goes into each of these options. 26 options, 26 options, 26 options, and then the digits could be 0 through 9, so that's 10, 10, and 10 options for each of those digits, numerical digits. So, counting principle, you just multiply all of your options. So 26, I'm going to just do to the third because that's a little bit easier. And then 10 to the third would have 3 zeros. 26 times 26 times 26 was 17,576. And then times 10 times 10 times 10. Each one adds a 0 like our calculator showed. So that's a lot of 17.5 million. That's a lot of license plates. Assume that a password to log into a computer account is to consist of any 4 digits or letters, and repetition is permitted. Determine the number of passwords possible. If the letters are not case sensitive, so that means it doesn't matter if you do capital or lowercase a or whatever, it's treated the same way, so that means there's only 26. If capital mattered, then you'd have 26 lowercase and 26 uppercase. That's the only difference there. So 26 letters, or it could be digits. So plus 10, so that's 36 options for each space. And it's a 4 characters. 1, 2, 3, 4. And it says repetition is permitted, so that means 36 and then 36 again, because we can repeat. If you cannot repeat, then those would decrease. So we got 36 to the 4th power there. One, 6, 7, 9, 6, 1, 6. And again, if you want to fill in your commas, that is 1,679,616. Lots of options there. Alright, so now the letters are case sensitive. Still, and I guess repeats are still allowed because it doesn't say differently. So if the letters are case sensitive, that means instead of 36, there's going to be an additional 26. Because you can use each uppercase letter or lowercase letter. So that is 42, 52, 62 in each position. So 62 to the 4th power, 1477 6336. 14 million options, almost 15 million. All right, you have 8 books. You can choose only 4 to put on a shelf. How many different ways can you arrange the books? Strange question, but the idea here is you can't put the same book up there twice. So that would be like no repeating. We're only putting 4 books up there, so we'll put 4 spots. So now we're just going to think through it. We have 8 books to choose from, so you could put any of the 8 there. But now that that one's gone, we've got 7 options. Now that both of those are gone, there's only 6 options for that spot, and then this last one, it's only got 5 options. So that's 8 times 7 times 6 times 5. All right, if the first 2 books, so now you're deciding, okay, I need this one to go first and then this one needs to go second. So you're taking those out of the equation. Those are locked in. How many arrangements can be made now? So we still have 4 total. We already took these 2 away because that one's locked in, that one's locked in. We only have 1 option there, 1 option there. So now that means we only have 6 more books available for that spot and 5 more books available for that spot. Multiply that out. 6 times 5 is 30. So now there's only 30 arrangements that can be made. At Old Navy, a supply of solid colored t-shirts has just been received. The t-shirts come in the following colors: green, blue, yellow, white, and red. The manager decides to display 1 of each color in a row on a shelf. How many different ways can you display the 5 shirts on the shelf? So he's got this row. He wants 1 of each, so that means he's going to be putting 1, 2, 3, 4, 5 shirts. 5 shirts. The first one, he could have any of the 5, but then he's not going to repeat. So then it goes down by 1 each time, and we get, that's 20, 60 times 2 is 120. 120 different ways to arrange the shirts. Similar concept here to what we did on the last one with the books. He wants blue in the middle. So that means this one has 4 options and 3 options and 2 options and 1 option. So when we multiply for the counting principle here, that's 12 times 2 is 24 times 1, 24 options. If he wants the white t-shirt to be first and the blue to be last, how many ways can he arrange? So again, we've got the 5 spots. We're locking in white there and blue there, which means there's 3 shirts left. So you have 3 options, 2 options, and then 1 option. Now there's only 3 times 2 is 6. Only 6 ways to arrange the rest. All right, here we are back to computer passwords. 2 lowercase letters followed by 4 digits. Determine how many different passwords are possible. If you are allowed, so it's 2 lowercase letters followed by 4 digits. The lowercase letters, there's 26, and you can repeat, so it's 26 and 26. And then the digits, there's 10. (26) times 26 times 10, 10, 10, 10. That's going to add 4 zeros onto that. So 676. And then each 10 just adds a 0. And if you want to put your commas in there, it's almost 7 million. A little bit less. Repetition is not permitted. So same thing, but you cannot repeat. So it's 26, but then we only have 25. And then starting over with the digits now, there's 10, but we can't repeat, so then that's 9 and 8 and 7, but it's the same 2 letters, 1, 2, 3, 4 digits, 4 numbers there. 26 times 25 times 10 times 9 times 8 times 7. 3276 with 3 zeros. First letter must be a vowel, and the first digit cannot be a 0. So same 2 letters, 1, 2, 3, 4 numbers, and repetition is not permitted. So the first must be a vowel. Let's go ahead and say vowels are only A, E, I, O, U, no Y in this case. So there's 5 vowels. And now we've used that letter, we cannot repeat it, so now there's 25 more letters left. And then it says the first digit cannot be a 0, so it's not going to be 0 through 9, it's just 1 through 9, which is 9. And now we can't reuse that, but now 0 is an option, so now there's 9 options, followed by 8, followed by 7 options, because it keeps decreasing. So let's multiply that out. 5 times 25 times 9 times 9 times 8 times 7. 567 and 3 zeros. 567,000. All right, so that was all the counting principle. Permutations is very much related, but permutations, what that really means is you cannot repeat. So it's any ordered arrangement. The order does matter, but you're not allowed to repeat. That's the main thing with permutations. So here we go. So this one of the things that we're going to use for permutations is the factorial symbol. And got messed up over here. There we go. So the factorial symbol is this exclamation mark, and what it means is you keep multiplying as you count down. So 5 factorial would be 5 times 4 times 3 times 2 times 1. You count down and you keep multiplying. So when there are 7 children to be arranged in a line, the way we were doing that with just the counting principle said we would have 7 spots. And then the first one you could put any of the 7, and then 6, because you cannot have the same child in each 2 different spots. That would be weird. Times 4, times 3, times 2, times 1. Now if you look, since we're using all 7, unlike that book example we did earlier, it counts from 7 all the way down to 1. That's 7 factorial by definition. That's what factorial means. So the useful part is that is in your calculator. I think it's here in option, hopefully. And then we'll, scroll over to probability, P-R-O-B, probability. It should be in here, I hope. Yeah, there it is. The exclamation point, the X with the exclamation point. So type in the number first, 7, and then that, and it will do factorial, and that multiplies out. If you're not If you don't trust the calculator, you could always type it out just like we wrote it out. But that's right, 5,040. So there's permutation notation, kind of a strange phrase there. It's just the number of things. PR is how many you're taking at a time. So in that last example, that would have been a 7P7 because you're using all 7 children. If you were in that book example, it would have been more, what do we have? I think we had 8 books to choose from, and we only took 4. So that book example would have been an 8P4 because you're only using 4 of them at a time. And there is a formula. It's also built into your calculator, so you would probably do this with a calculator no matter what, so you might as well just use the button on your calculator, which is right here next to the factorial symbol anyway. So you do have to type a number first. So that last one we said it would be a 7P7. So we do 7P7, and we should get that 5,040. And on that book example, I don't remember what our answer was. Let's see if this reminds us. 8P4 would be 1680. Let's scroll back. Let's see if that was right. 1680. So those are, but this is the formula. You subtract the 2 numbers for the denominator, and then that first number just goes on top. Now the easy thing about these, if you are doing them by hand, when you subtract like this 8P4, that would be a 8 factorial over 8 minus 4 would be 4 factorial. The easy thing about it is this denominator, actually, you can think of it as that's just when you stop counting. So 8 factorial would be 8 times 7 times 6 times 4. Not stop counting at the 4 necessarily, but you stop counting after, when you reach that basically. So let me write it out and it'll make sense. So then we would divide by 4 times 3 times 2 times 1. I totally skipped over 5. Eight times 7 times 6 times 5, 4, 3, 2, 1. So as we're going through this, once you write it out, if you write out what all the factorial means, it's super easy because you can see the 1's cancel, the 2's will cancel. That's the way multiplication and division works. So what I was saying is you stop after when you would get to this 4 basically. Or for permutations, this back number is also going to tell you how many spots to count out. It just so happens that it was 4 anyway, so 1, 2, 3, 4 spots. We're going to keep the first 4 numbers only. A little bit confusing, but we'll see it here in a second. So 8P4, we just did that on the last example. 1680. P5. I don't like this one because it happens to be the same situation again. But 10P5 means we would go 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over the denominator. We do 10 minus 5 is 5. Then you go 5 times 4 times 3 times 2 times 1. And then 5, 4, 3, 2, 1 cancels 5, 4, 3, 2, 1. Or you can just type it into your calculator. 10 P5 30 240. All right, 9p3. I like this one a little bit better. So remember, the long way, the formula way, is you do 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over the denominator. You subtract those. So 9 minus 3 is 6. So that's what we do on the bottom. 6 times 5 times 4 times 3 times 2 times 1. And then 6 through 1 cancels 6 through 1. Now notice it just leaves you 3 numbers. So when I do permutations, I don't actually use the formula. I instead say that 3 tells me to put 3 blanks, and then I just start counting from 9. 9, 8, 7. That's all you're multiplying. 9 times 8 times 7, not a 4. 7. It's 504. And then again, that should have been 9p3. We can check that. 9p3, 504. If this is less common, but the number, if you have duplicate objects, the number of arrangements are identical, and the number of the second arrangement are identical. So we've got this little bit different formula. We just have all these different ends in here. But this would show all the objects that are repeating in the denominator here. These would all be the repeating things. All right, so we're going to rearrange the letters in the word Tallahassee. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. But there's a whole bunch of repeats. T does not repeat. A repeats. It repeats once, twice, 3 times. L repeats twice. H does not repeat. S repeats twice, and E repeats twice. So like we said back here, you take the number of objects, so there's 11 letters, and then the things that repeated. So we had all those letters that repeated. We had 3 A's, 2 L's, 2 S's, 2 E's. Those were our repeats. And the numerator is just the 11 factorial. So you can type this out exactly as is. 11 factorial, that would make sense to type into our calculator. Our denominator, it's not really worth typing in all those factorials because this is 2 times 1, 2 times 1, 2 times 1. So this is 2 times 2 times 2. That's just 8 right there. And then 3 factorial, that's 3 times 2, that's 6. So our denominator is just 6 times 8, which is 48. Little mental math, I think, was easier than pressing all the buttons on the calculator. So we do 11 factorial, and then divide it by 48. That's all our denominator is. 831, 600. There's just one more thing to add on, just a fact. 0 factorial, which is weird because remember we said we count down, but if you count down from 0 to 1, you can't even do that. 0 factorial is actually just 1. That's something just worth memorizing, basically. But it also comes back to when we did this 8p8, or actually I think we did 7p7. Remember, our denominator when we do this would be 8 minus 8 would be 0, and that's kind of where it comes from. So you would have 0 factorial, so that just means the denominator is 1. Doesn't anytime these two numbers match, the denominator is just 1. All right, that's it. Find your homework, your worksheet in the Files tab and get it submitted to Student View. And as always, post your comments and questions, and you'll hear from me in the next video. Bye.